Assalamu alaikum everyone. I am Maria Vakas and I welcome you all to this new semester, spring semester 2020. I'll be teaching this course CS116 Object Oriented Programming. Fortunately, we know each other already. We had been together in the last semester as well. And from the time that we spent together and from the end result that we got, I conclude that it went really, really good. So this time, this is different uh, and it's a little difficult as well because we are not used to this format of teaching. But I'll try my level best to make things easy for you, and I expect your best effort in return. And together we'll make it work, inshallah. So let's get started. Okay, CS115 Computer Programming, or simply CP. This was the course that we studied during last semester, and this course will serve as the prerequisite to this course. To this new course, Object-Oriented Programming. In CP, we studied the fundamental programming structures like decision making, iterations, how to write functions, how to save records in a file. And we also developed a couple of small scale programming applications using these fundamental concepts. The programming language that we used there for implementation was Python version 3. So we'll be continuing with the same programming language in this course of object-oriented programming as well. Now, this new course or object-oriented programming, it's about a new style of programming. Like it's more about design concepts rather than learning syntax or structures. We'll be using all those structures that we studied during the last course, and we'll be learning a lot of new structures as well. But uh, for me, it's more about how you address a programming problem. Like it's more about design concepts, programming design concepts. And you will see that this is a very, very popular way of programming nowadays, and you'll find it really effective, especially for complex programming problems, right? Now, this is the course plan. In fact, tentative week-wise course plan. Objects, classes, inheritance, polymorphisms, these are all the major concepts that constitute object-oriented programming. I have uploaded a detailed course outline on your Google Classroom also, so you can refer to that if you want to see the subtopics. Hopefully, all of you must be familiar with the concept of OBE system, outcome-based education system, and CLOs, course learning outcomes. You are supposed to clear a set of CLOs in each course, and these three are the CLOs which you are required to attain for object-oriented programming. Now, taxonomy level, it basically refers to the cognition level. The two cognition level that we'll be using in this course are C2 and C3. C2 means comprehension and C3 refers to application. So that means that by the end of this course, you should be able to describe and you should be able to explain fundamental concepts of object-oriented programming, uh, as CLO1 says. And according to CLO2, you should be able to apply those fundamental concepts to solve real world problems, right? That means you'll be applying the basic concepts. That is application level, C3, right? Now, the third CLO is tied to the practical work. And if conditions are right, then you will be having a 4-week practical session after completing this 10-week online session, right? Um, but this is a programming course. How to program. You are familiar with Python IDE, which is called idle. So we'll be doing a lot of hands-on practice in this online portion as well, right? So we cannot in programming courses, you just cannot separate out practice and theory like in other courses, right? So we'll be doing both the things simultaneously. Okay, this is the list of books that I have selected for this course. The first one by Dusty Phillips, Python 3 Object-Oriented Programming. As the name suggests, it will introduce you to the syntax of Python language, which is used to implement object-oriented programming concepts. Uh, it this book, it almost covers all the topics that we'll be discussing in this course. The second one, Object-Oriented Thought Process by Matt Wiesfield. This is a really, really good book when it comes to concepts of object-oriented programming. And it is one of the top books on this subject. And but there is a little problem in this book, and that is that the code given in this book is in Java. It's not in Python, but it's in Java. But still, you'll find it very, very useful if you want to learn the concepts. Like it's a very, very comprehensive and a complete book on object-oriented programming concepts. Okay, last two books, you are familiar with these books. These are the books that we had been using during last semester also for CP, right? And these are there so that you can refer to the basics if you want. And these books, they also include some portion of object-oriented programming. So whatever we'll be discussing in class, you will find that topic in any of these books or all of these books. And you always know that there are a lot of online resources also on object-oriented programming as well as on Python programming. So you can see that too. I have uploaded soft copies of all these four books on your Google group already, right? Okay, this is the grading criteria that you already know. For a 3+1 credit hour course like CP and this one, object-oriented programming, you have got a total of 150 marks, 100 marks for theory and 50 marks for practical. And these 150 marks collectively decide your final grade, right? Now, these theory 100 marks for theory, they are further divided into sessional evaluation and final exam, 40 marks for sessional evaluation and 60 marks for final exam. Like last semester, I am not sure that we'll be having midterms or not, or what will be the format of these midterm exams. So leaving them aside, this is my sessional criteria for now, right? You will be evaluated mostly on assignments. So 10% weight is for assignment, and you will see shortly that CEA, complex engineering activity, is also a kind of assignment. So you will be evaluated mostly on assignments. This first one, quizzes, question answer session, this relates to your performance in live sessions. Now, on this note, I would like to explain a little bit about the format, like we will be conducting these online sessions. At the start of the week, I'll upload 3 lectures of 40 minutes each with supporting materials and assignment details, if any, right? You are supposed to watch these lectures. You are supposed to attempt those assignments if you can, right? And then in the following week, we'll be having a discussion session on the work of the last week, right? So when you are coming to the live session, I'm expecting that you have watched all those videos, right? So this is not much if you consider a single course. Like watching 3 videos of 40 minutes each is not a big task. But keep in mind that you have to watch similar videos for other 4 or 5 courses too, right? So that means that you have to be disciplined and you have to manage time, right? So you will gain these 10% marks for question answer sessions only if you come prepared in those live sessions. Like you should know what the content was. You should come up with your questions, with your problems. And if I ask you any question during the session, you should be able to answer that, right? So, okay, last one, complex engineering activity. It sounds a little heavy, but actually it's a small project like you did in last semester. A small complete application which will use all the concepts that we'll be studying in this course. So it's a design project on programming, right? And that will carry 20% marks. So I'll share the details of this complex engineering activity later in this course, right? Now, I would like you to keep certain things in mind before starting the course. First of all, as I said earlier, this is a different mode of learning, and many of you might find it difficult as compared to what we had during the last semester. Uh, Initially, I would try to go a little slower, but eventually we'll pick a little speed. So overall, it's a fast-paced course. And as I said earlier, that I'll try my level best to make things easy for you. But ultimately, the greater part of responsibility lies with you. So you have to be extra disciplined and you have to do extra effort if you want to achieve something at the end, right? Make a regular schedule, follow it strictly in order to cope up, right? Secondly, I hope you all remember the 3 P's of programming that we discussed in CP. Those were practice, 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 right? These 3 P's, they still apply. So I can explain you the concepts. I can tell you the syntax of Python. I can solve problems with you, I can do a lot of examples with you, but still I cannot put programming skills into your brains, right? So if you're not getting along, you know what to do. You just have to increase these number of p's, right? The more you practice, the better programmer you become. And lastly, uh, as I told you earlier, that major part of assessment is based on these assignments. And if you are submitting copied assignments, I might not know. Like sometimes I'm able to detect, and sometimes I'm not able to do that, right? But again, it's for your own benefit. The more you practice, the more you learn. If you're solving those assignments by yourself, that means that will help you become a better programmer. And needless to say how important this course is for a computer engineer. Programming is one of the most essential skills for a computer engineer. So if you are not learning it now, then you will suffer later in the field, right? So try to do the assignments by yourself. If you are facing any problems, you can always contact me. We can discuss that in live sessions, or you can send emails with your problems to me, and I'll try to timely reply them. And let's see how it goes. Okay, in the remaining of this session, we'll see these two computing paradigms, procedural programming and object-oriented programming. We'll see what these paradigms are about, and we'll see how they are different from each other. I'll start by highlighting the difference between these two programming paradigms or programming approaches, procedural programming and object-oriented programming. Now, procedural programming is what we had been doing during the last semester. So let's recap that first. So what we used to do whenever given a problem, we used to develop a list of instructions or a series of steps on paper or in mind, and then we used to convert that into Python code, right? Now, if the problem gets larger, what we used to do, we used to develop individual functions, we used to implement them and test them separately, and then collectively they made the whole thing works. Now, this is a top-down approach, because what we are doing here is we are dividing the problem into tasks, and then we are dividing those tasks into subtasks and so on. So we develop the main module first, and then we develop the next level modules, and this procedure continues until all the modules are developed, right? This is a very easy approach, easier to understand, because this is the natural way of thinking. We start with a procedure in mind, and then we go about. So what about data in that paradigm? We did not give any specific attention to data. We used to write functions, and we used to define data as per need, right, along the way. Initial languages developed, they were all procedural languages like Fortran, Basic, Pascal. These are not used nowadays, but C is a relatively newer as compared to these three, and it's a very popular language too. These are all procedural programming languages. Now, the advantage of procedural language, as I just said, that it was easy for writing a small program, because you had to just think of the procedure, and then you just convert that procedure into code, right? Now, again, if the program gets bigger, you divide it into functions, and then you implement and test those functions, and then you combine them all. That was easy to handle, right? Easy to code and easy to handle. Now, as the program size gets even bigger, we start to see certain problems with procedural style of programming. The first one is that although you are dividing your program into smaller functions and you are modularizing your program, but still your code becomes difficult to conceptualize and handle after a certain point, right? Second is that unrestricted access to global data and functional interdependencies make the code difficult to modify, and it can result in unintended consequences, and it can even cause your code to crash. Now, in order to understand these 2 points, especially the second one, let's consider an example. Let's suppose we have these pieces of global data. Now, by global data, I mean the data items that you define in the main program. Right? Now, let's suppose you write a function and you want to access those globally defined data items from within that function. You have two methods for doing this in Python. First of all, you can pass these global data items as parameters to the function, right? Secondly, you can use a keyword that we studied, global, right? You can use this keyword and you can access any data item from the main program directly from within the function, right? Now let's suppose I write a function, and this function is accessing these two pieces of data, of global data, right? It doesn't matter which method you are using, parameter passing, or you are just accessing these data items directly or globally from the main program. So let's suppose this function is accessing these two pieces. Now I write a second function, and this function accesses all four pieces of data. Now you see uh, some functional interdependencies are starting to build. There are data items the first one and the third one, which are accessed by both the functions. So if one functions, like the yellow function, if it changes the value of any of these two data items, that change might affect function, the green function, right? So and that green function might not be prepared for that change, so that function might stop working, right? So now if I define a few more functions, so what we can see from here is that the interdependencies, they are increasing. The more the interdependencies, the more difficult it becomes for a programmer to keep track that for each data item from which functions it has been accessed, right? So the problem is that the complexity is increasing, and such a scenario is difficult for a programmer to understand, and more importantly to debug. Like if the program crashes, it's very difficult for a programmer to find out that which change did that. For example, if this red function is changing a data item, and that's affecting the green function, it might take some time for the programmer to figure that out, that what's actually happening, like why the code is not working, right? So this is one of the main problems of procedural programming, these dependencies. So the second approach that we'll be seeing, that object-oriented programming, there we'll try to reduce these dependencies, or we'll try to handle these dependencies in a more organized way, right? So that the scenario becomes easier for the programmer. The third thing the third point is this, that in procedural programming there is no way of attaching a data item to a functionality, right? You define data items as per your need. If you are defining a data item globally and you are writing a function which manipulates that data item, there is no way in procedural programming by which you can show that this function is actually associated with this piece of data. Now, in order to understand this, let's see an example. Let's develop a small real world application, and in this example I'll try to highlight the problems that procedural programming or procedural way of programming can cause as the code size grows. Now what I plan to do here is, let's suppose I want to start a business. I want to make and sell some samosas and rolls as it is trending nowadays. So I open a bake shop. Now I want an application or a small program to keep track of my sales and account for my shop. So if thinking in procedural way, what I would do, I would first think of certain functions that my application should be able to provide me. So here is a small list of functions that I want to implement for my bake shop. The first one, it will help me add numbers to my stock. Like it will maintain a number that will show me that how many samosas and how many stocks, how many rolls are there in my stock. The second one is just a getter function, and it will show me the current status of my stocks. And the last one, it will help me take orders. It will help me calculate bill. And if I'm selling those samosas and rolls, then obviously the stock will I'll need to adjust the stocks, right? Now these three functions, while implementing them, I might need certain variables. So let's suppose I define these variables along the way. The first two, they could just be integer variables, and they'll keep track of how many samosas and rolls I have in stock. And the last two, they are setting the unit price for each item. Now these unit prices, they'll help me calculate the bill, right? Now this is first set of function and variables, and they are all related to food items. Now let's suppose my business grows, and now I need to hire a couple of employees too for my shop, right? And now I want this application to keep track of my employees accounts too. So I add some functions for my employees. The first one, will help me set wage rates. Let's suppose I pay them differently depending on the nature of their jobs. And the second one, actually I plan to pay my employees on hourly basis. The more hour they work, the more payment they'll get. So the second function, it will just keep track of the hours they have worked in a day. So at the end of the day, I'll just add a number here, and that will add up to the total hours they have worked up till now. So and then at the end of the week or at the end of the month, I'll use these hours worked and wage rate functions or variables that I'll show you in a while to calculate the final payment of my employees. So again, for these functions, I need certain variables. Let's suppose these 4 self-explanatory names, these are the variables that I am using with the later set of functions, last 3 functions, right? And these 4 variables and these 3 functions, they are related to the employees. Now, up till now, if you see, I am talking about 2 objects. One is the food items and the other one is the employees. And there is no dependency between these 2 sets. But I can create a dependency here somehow. For example, I want to add another function in the employee part, and that is called calculate bonus. What I want to do here is I want to pay some extra bonus to my employees if my sales reach a certain mark, right? So for this purpose of for calculating bonus, I add a new variable to total sales. Now this total sales, I'll compare this variable with a certain mark or with a certain number, and if total sales they are more than this that particular mark, then I'll calculate some extra payment for my employees, right? Now up till now, what we have seen, as I just said, that first 3 functions and first 4 variables, they are related to one object, which is called food. The next, they are related to employee, and they are not that much interrelated up till now. But the last variable, total sales, it is dependent on more than one function, because this variable will be calculated by this function, take order, calculate bill, and adjust stocks. Obviously, bill calculation will help me keep track of my total sales, and last function, calculate bonus, will be using this variable. So now I have created a small dependency between the 2 objects, food and employee. So there exists a variable that depends on both. Now let's suppose the employees that I hired, they are really hardworking and honest, and and now I am getting some free time and I know stitching too. So I open a boutique also alongside. And now I want this application to keep track of my boutique accounts too. So what I need to do here is, now I need to define some functions related to my boutique, and I want to define some variables for that along the way. So what I want to show you here is that the application size is growing. Now again, you might think that the third set of functions and variables, or the third object, boutique object, it is really independent of the other 2. Then, but again, I can create a dependency here. Let's suppose I decide to give a dozen samosas as a gift to a person who is buying clothes of more than 10,000 from my boutique, right? So that means that sales of my boutique, they'll affect my samosas stock in this case, right? So again, in larger applications, such interdependencies, they naturally exist, right? Now up till now, what we have seen, that I have defined 3 objects here: food, employee, and boutique. And for most part they are independent of each other, but there are certain variables which are interdependent on each other, like variables of one object, they are dependent on the functions of the other objects, etc., right? Now one problem here in this code, if it is a procedural code, is that, let's suppose I want to make a change in this code, a small change. Let's suppose I want to change the name of this variable. I don't like this name samosas, I want to change it to something trendy. Let's suppose now I call it triangular pockets. Okay, because it looks, trendier, or it looks better. Now if I change this name, what I have to do, I have to make a lot of changes in other parts of the code too, because this was the variable which was used by more than one functions. And if I'm changing the name, then I'll have to go to those functions too and make the changes there also, right? Now for small code, this is easy, but as the code size becomes larger, it becomes harder to keep track of the changes. So in other languages, your compiler, it might give you syntactic error if you failed or you just forget to change this variable name at certain places. But with Python, there is another problem. Python doesn't use data types when defining variables. It automatically detects data type for an object, right? So it may happen in Python that you change this name samosas to triangular pockets at some places, and and at some places you just forget, or you just overlooks, and you don't change it there. So what will happen uh, in Python, it is quite possible that both name exist. At some places it triangular pockets is used, and for the same purpose at some places samosas is used, right? And that will not raise any syntactic error, but your code will not work correctly, because that's how it is not intended to work. Same name should be there at all the places. So it will give some logical error. Your application will give logical errors, and it is also possible that at some point of time your code might crash, right? So the point here is that it is really difficult to make changes in procedural code, because then it becomes hard to track those changes, and it becomes hard to debug also, right? That was first point. Second point that we discussed in fact, that was the first and second point. And the last point that we discussed in the last slide was that a procedural application, it does not keep the variables and functions together. For example, in this application we have three objects: food, employee, and boutique. Let's consider food only. First four variables, they are related to the first three functions, but there is no way by which I can show that these two are related. Like, I am the programmer, I wrote the code, I know that these variables are related to these functions, but my machine doesn't know. And if there is another programmer who is trying to edit my code, he or she will also have a very hard time in finding out that which variables are related to which functions, right? So there is no way of tying them together explicitly. And that's what we'll see in this next paradigm, object oriented programming. That double OP programming, it gives us functionality to implement or to remove all these problems, right? Now, having said that, writing a procedural code for this application, for example, if you are able to write a code for this application and you are able to run it successfully without errors, then that is absolutely fine. There is nothing fundamentally wrong in writing procedural code. The only problem is here is this, that it becomes difficult to manage when the code size grows, right? So object oriented programming basically provides a better and a more organized way to write larger applications, or to write such codes which involve multiple objects, and then there exist a lot of interdependencies between those objects. Their object oriented paradigm is a better choice. So let's see that now. Now let's see what object-oriented programming is. In object-oriented programming, we start by defining objects. An object is an entity which is composed of two parts: data and behaviors. Like in last example, we saw that food is an entity and it has some data items or variables associated with it, and there was a set of functions associated with it. So those data items, they represent the attributes or properties or simply data, and the functions that we defined, that indicated the behavior of that object, right? And but the only difference is that in object-oriented programming we call those functions methods, right? So fundamentally, methods and functions, they are same things, and they are defined in almost the same way in programming languages. Now, for example, a person can be an object, and a person has some data items associated with him or her, like eye color, age, height, and so on. And the same person can have some functionality or behaviors associated with him or her, like walking, talking, breathing, and so on. And if you recall from the last course, we said that everything in Python is an object. I'm an object, my laptop is an object, table is an object. For example, if you are considering table as an object, then table can have attributes like table color, material with which it has been made, and then the same table can have some set of functionality like place on table, place something on table, remove from table, etc., etc. Like, it's up to you how you think about it, right? Now, this is a bottom up approach. By bottom up approach, I mean that if you are developing an object oriented application, or if you are trying to design a programming problem from object oriented view, what you will do, you will first identify and define and test the objects, individual objects. You will define small objects in your scenario, and then you will develop objects for those things, right? And then what you do, you interlink those objects, and then you build newer objects, and then those objects, they can be called by the main program, and then you slowly go upwards, right? Like, you start by building the basic objects, you interlink them, and then you interlink those objects with the main program, and then you are going from bottom to up. Now, such an approach is suitable in many scenarios. Okay, before that, let's see some programming language examples. Almost all modern day examples used nowadays, general purpose languages, they are object oriented, like Java, C++, Python, C Sharp, PHP, JavaScript, Ruby, Perl, Swift, Scala. They all are object oriented languages, or you can say that all these languages, they have support for object oriented structures, right? Now, this bottom up approach, it is really suitable for real world problems, because in real world problems we have objects. So first, we'll identify and define those objects, and then we'll build the application using those objects. And defining objects this way, it also helps us to build scalable and reusable code. By scalable, I mean that you can, and reusable, I mean that you can use your older code and extend it and make newer code over it, or you can use older objects to build new objects. And we'll see that shortly in the upcoming lectures, that how we can do that. Also, such applications, they are easier to handle and easier to debug, and we'll also see that shortly in the upcoming lectures. Now, one more advantage of such applications is that these here objects, they are extremely secure. Like, we'll see in the next lecture that you can define objects, and you can put restrictions on the accessibility of its data and functions, and that can provide you a control over that object. So, like, whom you want to show your object, who can access your object and who cannot access your object, right? So therefore, such applications, they are very well suited for the use on networks like internet and mobile web, right? So most of such applications and network applications, they are object oriented by nature. Let us now revisit that bake shop application again, and this time we'll try to build it in object oriented way. So if I want to build it in object oriented way, what I have to do, I have to identify the objects first. So if you recall, we had three objects there: food, employee, and boutique, right? So I'll start by building or writing code or thinking about my first object first, and let's suppose we start with food, right? Now, this object can have two attributes. It can have some attributes associated with it, right? And it can also have some methods associated with it. Now, the difference here is that we are placing these attributes and method in this object food, or along with this object food. So this whole thing is kept in a capsule kind of a thing. Like, you cannot access these attributes and methods without instantiating this object food. So that is the concept of an object. Like, this is a single entity, and these attributes and these methods, they are tightly coupled to this object name food, right? Now, similarly, we can define another object, which is employee, and for employee, we can have some attributes, actually the same attributes and some methods, right? Now, this is another capsule, or this is another, you can say, another box in which you are placing these attributes and method, and you are tying these to a new object called employee. Now, we have developed two objects, and after developing the objects, what we'll do, we can see we can interlink them, like they might be calling each other's functions, and they can also be called by the main program. Now, this is a bottom up approach. Like you started with defining the objects, and then you went upwards, right? Now you can also notice here that I place the calculate bonus function in employee, and I place the total sales variable in food. And obviously calculate bonus will ask that object food if it can have access to total sales, and food is responsible for providing access to this variable if somebody requests the access. Now similarly, there was a third object also, that was boutique. So in such an application, you can define a separate independent object boutique. You can define attributes and methods. You can build it and test it separately, and then you can integrate it with your main application. So this is object oriented approach. Now, this is just the basic difference between object oriented way of programming and procedural way of programming, which we explored in this example. However, there is a lot more to object oriented programming. There are a lot of features or power that object oriented provides, which make it a natural choice for complex real world applications. Let us now compare these two paradigms side by side. What we have seen up till now is that in procedural programming, the problem is divided into functions, whereas in object oriented programming we start by developing objects. The second point which we saw was that in procedural programming, attributes and behaviors, they are kept separate. Like there is no way to tell that if a data item is linked with a function. Like machine cannot tell that. uh, Whereas in object-oriented programming, there are structures which allow you to place attributes and behavior in a single cover, in a single capsule, and that capsule is identified by the object name. So that structure helps the machine identify that which objects or which attributes are related to which object, right? The third point which we explored was that procedural programming is a top-down approach. Like you start with a bigger problem, you divide it into smaller chunks, and then you go downward uh, until the problem is solved. Whereas object-oriented programming, you just start from the bottommost. Like you start developing smaller parts, smaller objects, and then you interlink those objects, and then you build newer objects on top of that, and then you interlink those objects as well, and then a main program can use these objects. Like you are going from bottom to up in this approach. Now this security feature, we have not explored this feature as such in that application, in that example application, but we'll be seeing this feature in the next lecture. But I told you that object oriented programming, or encapsulating methods and attributes in a single object, makes that object more secure. Now, which approach to use? See, both approaches, they are used nowadays. Like you cannot say that procedural programming is obsolete. Like if for smaller programs we prefer procedural programming, as we had been doing in the last semester, and suppose there is an application in which there is a fixed set of objects. You don't keep on adding objects with time. There's a fixed set of objects and you just keep on adding functionality there. Procedural programming is a better choice, because procedural programming, since you are starting with a procedure in mind, so it is easier to conceive. Like from humans point of view, this approach is an easier approach, right? But from programming point of view, object oriented approach is a better approach, because if in an application you need to add objects, there this approach, object oriented approach, is better, right? Because it is more scalable, and it allows you to reuse older codes, so older objects, to build new objects. So there this approach is better. So the point is that you can use any of the approaches, and in fact most of the applications, they are using both the paradigms, right? Like it depends on you. Part of your application can be procedural and part of it can have objects, or I say that you can define objects also in the same application, right? And these languages which we said are object oriented languages, they can be used to write procedural codes as well. The special thing about these languages is that they have support for those special object oriented structures, which procedural languages do not have. So you can use C++ or Java or Python to write procedural code, as we had been doing in the last semester, and you can use it to write an object-oriented code as well, of course. But a procedural language like C or BASIC, you cannot use that language to write object-oriented programs, because it lacks support for those specialist structures that support object-oriented programming. Okay, this slide again, actually, it's an assignment. I want you to develop a procedural application for my bake shop. As I told you that whatever you studied in CP will serve as a prerequisite to this course. So the main purpose of this assignment is to make you recall those concepts, right? So because I'm pretty sure that many of you, in fact, most of you must not have accessed IDLE since your CP exam in January. So this will make you refresh those concepts, right? Now, what I want you to do is I want you to work on these three objects: food, employee, and boutique, and you will define at least 3 variables and 3 functions for each. For food and employee, you can use the same variables and same functions as I have already defined, but for boutique, you will have to work from scratch by yourselves, right? So now any further details and the grading criteria, we'll be discussing all those things in the upcoming live session. Okay, let's have a quick recap of what we have studied today. We discussed these two programming or computing paradigms: procedural programming and object-oriented programming. We saw that object-oriented programs, they are easier to debug and scale, and most real-world applications, they are inherently object-oriented. And most importantly, we discuss what an object is. An object is simply an entity which comprises of data as well as behaviors. So that's all for today. Thank you.